Well, hi. My name is Rachel Shearer. I now currently work for Sam Houston State University in the online as an instructional designer. And I am finishing up my dissertation. God played for me that I'd defend and everything's done at the end of July this month. Pray for me, y'all. Pray. Name is Rachel Shearer, Shearer Pennyhose. Some of you may have known me by Rachel Baxter. That's what I was previously until he lost those privileges. Anyways, I would like to thank you for attending this session. I know it's one of the on-demand ones. It might be something that's interesting to you and it might not. This is one of those things that's part of my heart and my soul as I really see the use of simulation-based training, or SBT, can really help us improve safety, like in the workplace, in the classroom. It can really help us to do different things and to be able to reach more students and do more things with more students. So thank you for attending. We're going to go through this and I'll explain some things. I do like to explain, oh my goodness, I apologize. Hello, what was that? Oops, that was not what I was studying. Anyways, I'm a mother of two young women. They're both proud graduates from Huntsville ISD. Their ages 23 and 21. Been in education for 26 years. This is going on year 7 in higher ed. So I actually have 6 years teaching junior high, and I taught junior high wood shop, metal shop. Yes, I was crazy. And then 13 years teaching high school, teaching everything from graphic design, engineering design, advanced engineering design, architectural, all that. So I jokingly laugh. I've taught everything from 6th grade to seniors at the college level. I've taught everything from art, woodworking, welding, all of that, to having students that are doing engineering design and building prototypes that are being tested for the ISS space station, working with NASA. So I've gotten to do lots of fun different things over the years. So for me, it's really fun, and I still get to do fun things. Student whisper, I laugh. Faculty, we have some faculty members that are beyond smart and smarter. They have forgotten more than I'll learn, but they don't always know how to deal with the students. And so either they come to me or they'll bring the student to me and we'll have a little talk. So they sometimes call me the student whisperer. I prefer, however, to go by simple. I'm their mentor, advisor, I'm their cheerleader. I'm there to help. I'm crazy for CT. If you don't know what CT is, it's current technology education. I'm massive. That is my area, my background. E-learning Jedi is kind of, everybody goes, oh, because obviously I have a thing for Yoda, if you didn't figure out the green ears. Gaga for Google. Oh my God, I was an early adopter of it. And it's not just Google, but I do love my Google. I love my Microsoft. I love my Adobe. I love my Autodesk. I love them all. Yes, I am a recovering shop teacher. I'm actually one of those people that actually knows how to do things. I'm at an age now where I like to supervise it, but I know how to do things and I can build things and put everything together. And it's a rather humorous to see people go, wait a minute, you actually know how to do that. But yes, you teach it to junior high kids. I taught welding to 8th graders, seriously, y'all. Curriculum translator, a lot of times, is looking at the curriculum and teaching new teachers really how to break it down and understand what you're doing. Ed techie. I love educational technology. I've been on it. I've loved it. Probably one of the earlier adopters back in, I was still teaching shop. So it was like my 5th year teaching, and I found ed technology and I was just like, oh, I love this. It's the future. We need to be able to do things. I am a volunteer addict. I should probably put a recovering band parent and band booster on there because I love working. I still volunteer and still do a lot of things because I believe in doing that. Either you put up or you shut up. One of those kind of things. So I am a volunteer. I do love. Essentially, if it involves working with others, helping others, if it involves CTE, if it involves the STEM, if it involves educational technology, find me there, you will. Because I really believe in it. I really want to give back and I want to help. I mean, that's what we're supposed to do. That's what we're in education for. Now, excuse me. If you start to look for simulation-based training or simulation-based learning or just simply simulation, and you look at it and you start reporting different things, you're going to find a couple of different areas. You will find it highly in medical, but you're not going to find it in other areas. I get asked a lot of times, why is safety even something that I need to be concerned about in the classroom? For CTE teacher and science teachers and art teachers, it is something, it is very important for us, simply because in CT, from teaching, some of the equipment they can use to make a bomb. If you've looked at some of the chemicals that are used by your cosmetology teachers, chemistry teachers, go talk to them because they can give excellent chemistry lessons and examples of different things that are going on. because they have enough chemicals in there. If they mix it, they could do some very dangerous work. I'm just saying. Same thing with your auto tech. And then you get into your science, and they're using a Bunsen burner, and they're lighting things, and they're not learning how to do this stuff and safety. So there's lots of things in there, and I can see that we can do pre-training and some pre-service and get students ready before they use the actual real equipment. And in the same thing in industry, if we're doing manufacturing, construction, we're training somebody on, for example, I know for a fact that falling from roofs is one of the number one killers in the construction industry. So if we're able to provide them with some simulated training on the proper way to hook up and go up and test and get on the roof to work on the roof, and if something happens and they don't do it properly and they actually get the instant reaction of falling off the roof and they kind of experience that, because you really can experience that. I can show you some videos, some links in this presentation, that they can learn that, and they can learn and teach it, and then get them working together, and they start learning spatial relationship, and then get more than one of them in the simulation and get those different things going on. So there's lots of stuff that are there. It's like something I just love it. It's something I really am interesting in, and it's fun for me. So the key is here, though, you will find when you go to start searching, because this has been something that has been part of my actual PhD studies, you will find almost 14,000 articles. These are peer-reviewed articles for health, for the medical fields. But then if you go look in manufacturing and construction, which are usually where we're going to have some of our higher safety issues, there's less than 6,000, less than half the number of same articles. So we know it's seen in health, and if it's seen as a viable use in health, why is it not being used in other areas in industry? Why is it not being used more for in the classroom? So for me, my next step is, after finishing this PhD, is to look at more the use of it in manufacturing and construction, and how can we train people and reduce incidents there, and how does that overflow into the classroom, and providing that for students to give them some of those intros while they're still in high school and learning about things, and then taking it and then going and getting their journeymans, or going to get their associates and then their bachelors, and going on to these different things and doing it, but getting them exposed to it sooner, and to make sure that it's really legitimately something they might actually be interested in. So I went through, and let's see if we could find and use SBT to improve safety and decrease the high cost of accidents. So we want to make operations less hazardous, less accidents, want fewer accidents, which results in less downtime and less production time. So if we're able to do things, that kind of thing, it's easy to reset if something does go wrong, but there's going to be less issues going on, because there's less, if an accident happens in a plant, usually they have to shut the plant down completely to do a complete report on what's going on. Same thing in your classroom. If something happens, you have to do an accident report. Everything must shut down. Every student must do an accident report, because you must have those on file in case something's happened, to see what's going on. And so you just lost all of that instructional time. It's the same thing. We want to reduce, obviously, harm to people that are within that area in that work zone, to chemicals, materials. Maybe an accident happens. This bolt is loose, and the crane breaks and falls. Different things that we have to really worry about. Better utilization of limited materials. We have so few teachers, so few areas and places where we can put the teachers and put the materials and do everything we need. If we can give that first introduction, that first basic, first 30 to 40% of instruction, 25% of instruction that is able to do it in a simulation, the students can verify and make sure it's what they want to do before we invest and we take them into going into the real world, or the applicable explanation, or the lab, the shop, etc., to learn. And let's just face it, I want people to be safe. That's the main thing, is can we make less casualties, less accidents, less deaths. So I use a descriptive theory, and when you use a descriptive theory, you look and you start looking for, okay, so according to BLS, Bureau Label Statistics, what industry is the highest? So I go and look. Well, yeah, they're going to tell me medical, manufacturing, construction. So okay, let's study those. Well, 60 to 80% of that are caused by human operators. So we know experiential training is hard to do. It's dangerous, expensive. Well, we know in this particular case that even though it might be expensive and they're not nearly as expensive as what they used to be, but to set up a room, if you're going to do a virtual reality room, or if you're just going to do augmented reality, just my personal preference, but to set those up. I know they have the Google Cardboard box labs that they can go around and do things. So it's more safe, it's safer and affordable. Things are getting better. So we can also then, in theory, use those trainings to predict, well, if we do this, can we reduce accidents? What are the accidents happening? They're going on, what's going on in the training and not in the real world? So then hopefully we can reduce, therefore, the actual total accidents going on. So we can see, hopefully, industry numbers will go down. And so this is just why I use the descriptive theory. Again, human error is 60 to 80% of all the industrial accidents from all the nations across, specifically in manufacturing and construction. And that makes sense. It's going to be the same thing in the classroom. We know this. The student's not paying attention. You know, they're running down the hallway, they trip and fall. They don't have their hair pulled back when they're in the chemistry lab and their hair catches on fire. Little things like that are accidents. And no matter what you cover and you do everything you can to keep it down, you're still having that human interaction, so you're going to have the human errors. There's also an example that I was able to find in a report that crane operators face even more mental than they do physical demands. And something goes wrong with that crane, not only could it hurt the crane operator and everybody on his crew, but all those innocent people that are around. We use a lot of simulation-based training because it gives training beforehand and an ability to practice and fail, where if you fail in the environment and nobody gets hurt, nobody dies, nobody ends up on the 6 o'clock news. Instead of relying on just on-the-job training, which is OJT, or mentors that are there to teach her, so it's not putting all of the onus on the mentors, the teacher, but also providing them training provided by others and people interacting and going through theirs. All right, so how it can help. We know error is never going to be 100%. We still got people involved. But the goal is that at least it will minimize the number. And if it doesn't minimize the number, then it should minimize the severity of it. And we hope to see that, and we actually want to find that that is true. It allows for repeated practice, again, like I said, without worry, because they're going to mess up. And if they do mess up in the simulation, they don't actually get hurt. My actual current dissertation study is simulation-based training for new teachers before they go into their pre-service student teacher. And they go through a product called SimSchool, which is essentially a role-playing game. And they go into this and they practice teaching using the different avatar students that have set up to be different types of student. This student is going to be an ELEP student. This one's going to be a GT student. This one has learning. All these different scenarios that can go to these students, and they can practice different things teaching. Because for teachers, we don't think about the safety, or when we do think about safety, we're thinking about, oh my God, bombings or shootings and other horrible things. But safety in the classroom is important in education, because if we don't provide the best education possible for that student, if we don't connect with that student, if that student is told that they're dumb and they're stupid and they can't do something because they're being taught by somebody that doesn't understand how to reach that student and work with that student shuts down and believes that for the rest of their lives. We've all been there. So practicing and not actually practicing with actual students gives you an opportunity to try different things, because nobody wants to screw up, especially teachers. Nobody in education ever wants to screw up and be the reason that scars or harms a student mentally, emotionally, educationally. We don't want it. Simulation is great because it allows for experiential learning, that trial and error. They try this, reflect about this. Yes, it worked, it didn't work, we try something else. And it gets them to where they're able to start doing things where their responses are going to be more instinctual. So that muscle memory, we learn to do different things. Early adopters are in aviation, where we have the flight simulator. They use it because they report less accidents, increase the number of trainings are actually able to do things, less harms to other, etc., reduces casualties. I believe they can do, I have to go pull it up. I was looking at the most current law the other day, and I believe it's 10 hours of their 40 hours is used in simulation-based training in a simulated cockpit for doing things. Now there is the military. They find that using that Colby's experiential learning cycle is perfect for teaching and increasing the levels of the war games. They use it because it's high quality training that puts them in the environment where they're practicing and doing things, working as a group, but if something happens, they don't get hurt, they don't die. They're really, really good. Their mission rehearsals are really good. We see this used in police force training. All kinds of different things going on. It allows the trainee to get into different scenarios that those that have been there and have been experienced know this is potentially something you could run into. And so we can set up the training dilemma experience so that all the students, we know they're going to have to face and go through it. So they are getting exposure to it. The trainer is learning and seeing what it looks like. What are consequences that could happen when they do this in this simulated, this virtual environment? And it should, by practice and going through, prepare them for the real world. So early adopters of tourism, Google Earth VR is a massive one. If you've never done it, oh my Lanta, go and look. There's so many fun things you can do. You have students that you may come from a school where if they're lucky, they get out of the county. I've gone with students who have never before been out of the county except for with band. And then we take them to trips to Washington, D.C., or we take them to Disney or New York. And the exposure that they're able to get something they would never see. I will probably never get to go to see Italy and see the Venice Canal and all that. But using the tourism that is set up and using the Google Earth VR, I can experience it. I can get in there and I can see it. And I can be with the glasses and be within that environment. There's also the role-playing and storytelling, like I told you about Sim School, where they have them set up with the little avatar students. And each student's going to do different things for the lessons. And you can try this lesson and this different, okay, if that didn't work, well, how about if I do practice a little, get a little closer or work with the student, or I've prepared an alternate possible way of teaching it and providing it. There's different things you can do and you can go through. So it's a role-playing. It's a role-playing and a storytelling. You can do science experiments. PhET. Oh my God. PhET. If you do not know them, they are oh my God. Search simulations. Oh my God. I love these people for different science experiments. My students love doing it. They think they're just playing a game, and we play the game for a little while, and then we start thinking about it, and then we go, and then now let's see how it really actually works. Let's test it and do stuff. Oh my God, I love this, but it's great. The phobia therapy is used. Something that I would definitely need right here is I don't like heights. I don't like heights. I don't like heights. You should have seen me at the top. Anyways, I don't like heights in New York. The kids were laughing because they're like standing against the edge of the glass on, whoa. And I am like as far back from it as I can be, and I'm looking at, yeah, it's pretty. Yeah, my children, I had to turn around where I wasn't facing it, and the kids had to back me up so we could get the picture of all of us like leaning against the window, and then they had to help me to get back away from it because I couldn't move because I was scared, terrified. But phobia training, immersing you in situations and environments that scare you, so eventually you get to the point where it's less intimidating, less scary. They're used for teaching a skill, learning how to do something specifically, something that they can't necessarily get. I mean, they can only learn so much from us talking and telling, but when they start doing and applying, that's when they really start getting those higher levels and they really start to learn. And that is experiential learning. They're learning by doing, and then they do their reflection and they go, did this work or did not work? And the thing here is it's going to be an environment that nobody gets hurt, nobody gets killed, nobody ends up on the 6 o'clock news. You want to be on the 5 o'clock news. You never want to be on the 6 o'clock news, because if you ever pay attention and you watch the 6 o'clock news, it is never anything good. It is always something bad. How can we prove? We can get students training, and they say it takes about 10,000 hours to master a specific skill. Can we do all 10,000 hours in simulation? No. But I would argue that we could do maybe 3,000 hours in simulation training, and then getting into the skill and using the equipment and doing the things. The 2014 has got the best that you can find for actually defined, besides like aviation. They don't say percentage. They say 10 hours out of the 40 hours for, I think that's a refresher for part of your aviation training that's going on. National Council for State Board for Nursing says that 50% of simulation training can count, and then they have to do the other 50% in actual real world. So there are some that are defining what is the time and the amount that can be used for the simulation-based training for the SBT versus not in others. And it's worth studying and looking and see, can we actually do this? Kolbe's experiential learning model. So these are the basic 4 stages. And technically you can really kind of start, but typically we usually are going to start here. And you start in your concrete. It's experience, what you're feeling. It's what you're told, taught, you've seen, you know about, what happens when that procedure happens and doesn't. So we go from that, we observe and reflect, like, so we did this, what happened? Then we go into the watching stage, where they try to figure out why what they just did and saw happened. Was it a human error? Was it something other? Something could be done. This is probably, for us, truly one of the more important, or for me anyways, as an instructor, a teacher, it's the most important areas, because it's the student's reflection and the student applying it to themselves and thinking it through, and not just being told 2 + 2 = 4. Because I guarantee you, if you go talk to some people in Calculus 2 and Calculus 3, they will blow your mind, because 2 + 2 does not always equal 4, and they are being legit. So, but we want to teach them and take them past just memorization, but the application, looking at self-reflection, well, I should do this instead. So this is where it is. They reflect, they internalize, and they go forth. Then we get into thinking. And that's exactly where it is. It's like, okay, well, I just reflected and I'm wondering about this. So, what if I do X instead of Y? What kind of outcome do I get? And then that's, of course, where we get into the doing stage, where they spend arguably the majority of their time, they're actually doing things. And it allows them to think, do, practice, go through. And so they go through and they're like, oh, let me think about concrete state, feeling, how did this work? Their reflection. I watched and we did this, and the reflectance didn't work so well, so I needed, okay, let's do this instead the next time that I'm doing it. So we're taking them through this process constantly and evolving. And it should be constantly going on, because once they get to a specific part where they have mastery of it, they should then be able to go to the next part and continue the cycle and get even better and better and better as they're going through. If they do poorly, reflect, figure out what you did wrong, and keep going until you get it right. If they do good, okay, great. How can we do better and keep going? And this is really what a lot of the gaming, the gaming that we see now, the serious gaming, etc. That's what you see that's happened. That's what it's built on. It's built upon essentially the same model. And then again, there's your Smedes experiential, same thing. He says it starts in feedback. Then he says, come up with CZ, what's going to happen is going to happen. And then they go learn from the content. Did it happen? Did it not happen? And then they go and they do, and then they review and discuss what happened, and then they go back into the feedback after the experience, and they keep going. Okay. Now, I was able to find one study that specifically was focused on manufacturing field, that published into the study, and they used simulation-based training, experience and simulation, and experience only for a training for a tower crane dismantle. And so they had 30 identified questions, and they had them in working locations, and they checked and they monitored everybody, and they wanted to see if there's any difference between those that had experience only, those that had experience and SBT, or those that just has SBT. So if we looked first, well, looking at it, those that have simulation only and experience only are very similar, with highest being the one that has the combination of the two. So the question would be, why? When we look at the working location, same thing. Only simulation, only experience. They're almost exactly the same, but then they jump when we combine the two. So that's letting us know that simulation plus actual work experience seems to be really does work well. Same thing here. 7.8 and 8.2 of the sequencing. 8.7 it goes up. So each one of them, they're very similar if they only did the simulation training and only come with the experience. But when you take it and put those two together, you see a rise. And I fully believe, this is going to be one of those things, one of my studies I'm going to have to do, that the teachers, the new service teachers in my study that I'm working on for my dissertation, when they get that simulation training and plus the actual real training, simulation gets them prepared, gives them some ideas before they go into that student teaching component. And then as they're struggling and they're finding things, we can technically then identify actions and behaviors and try to an avatar, we assign things that they might be struggling with a specific student, so that they can try different things with that student in the simulation and try different things to work, and then go actually see, okay, well, this is how it worked in the simulation. Let's try it now in the real world of the student and see, does it really work? Does it not work? To help give them the tools that they need to build relationships and to have classroom management so that they can teach students. And then I want to see, I want to do a longitudinal study, and I want to do essentially like this, where we had teachers that only had SBT training and then they went into the classroom. And then I want teachers that have only straight field experience, traditional, and then I want some that have had a combination of both. And I want to see what is our retention rate after that 5 year? How many are still here? How do they rate what they've learned and their ability to meet with the needs of the students, and all those different kind of things. And I'm working that out. But I want to see, is there a difference? I want to track students. I want to do this because I want to see how that really applies for us in education. I also want to do this and see this and apply it for, in construction and training. I'm hoping to be able to start and work on a grant with the fire department and taking them through training, like how to get into a room and clear a room when you're going through the room that's on fire, and practicing going through that. And then see how we do in actual performance in that area for those, again, with only simulation, those with only field experience, and those that have both, and which of those groups, those 3 control groups, which one has a better outcome over a time period. I want to see these kind of things. So here's some examples of the current training screenshots. It's not super heavy in-depth graphics, but it works. See how it's got like the little red warning? In this particular program, these are each different people. And if this person does something, it could affect you. So you could be doing everything right, but because this person didn't, it could change the outcome. So that's one of those good things. They're now getting it in multiplayers and putting them in there. So let's go over the last part. Less hazards, less accidents in the real world. Allow that trainee practice that works towards that 10,000 hour rule for mastery. So 2, maybe 3,000 hours simulation, and then add in the real world and work their way through it. How does it improve? With less downtime? Well, if they're able to focus on what needs to be done, then they're going to be able to do it quickly, more productively, and they're going to be able to get their products into the market and the trained workforce much quickly. And then when you get a well-trained, quality-trained workforce, they stay, and you're not going to have to reinvest that time retraining them all over again. You just need to train them on new and more advanced. There are building information modeling software. So how does it reduce harm? Well, that's used a lot in construction management. We use the BIM software, and so they can actually develop virtual environments where a safety engineer can look at and identify where are hazards. Where if they drill into this wall, can they hit the electrical? Know when the electrical is. We need to make sure that we have a gate or something to block off so that they don't trip and fall off the end of the building. There's lots of different things that can go on in there. The Rapids Construction Safety Program at Civil and Georgia Institute has got lots of really cool and wonderful things. So if you want to go look for more on there, they were excellent. Lots of resources that are there for that particular one. But yes. The VCOM, optional use of materials. They have a digital. They take this program and they run this program through the simulate mock program and run it through. And they can find where the areas are where they're going to waste materials, where the people are having to work more, move more. They're not the most efficient use of materials in their folks. When using that simulation, they can go through in that simulated mock-up and they can find where the areas are. And once they find those areas, they can address them and fix them. And then their production time went up by 30%, with so much is going as much as 50%. So that's, hey, it works. And then less operator error. The more educated you are and the more times that you've done something, the less likely you are to mess up. It's why it's so important that we keep experienced people in their areas. It's why experienced teachers are so important, because they pass it on to the next ones that are coming in. They have those different, but we have a high in industry, not just in education, but we have a high group that demographically that are going to be retiring and leaving, and we're losing all of that knowledge that they've got, and we have to start over again and build back up. And if we're able to use simulation, and they help us create and build these simulation, and they share these information that's going on, we can learn from them, and then we can do better. And they were quick. Things are quicker. It's easy to work through reset. So yeah, we have to think about those kind of things, and I do think about those things, and I do worry about those kind of things. I know I'm weird. It's okay. So, brutally honest, we really do not know for sure what simulations are going to end up really looking like. You know, I truly, if you think about it, right now, the current VR, it's essentially like the holodecks that you see in the sci-fi, like in Star Trek, where they have the holodeck and everything's in there. Only you're in glasses and you see all of it. Well, when the full holodeck is actually more of an AR environment, where it's you inside of the environment and the environment's changing and going through. But it's super realistic. And you can do things in there, and you can practice. And if it doesn't work, you find out it didn't work. You don't die. You're not on the 6 o'clock news. And let's reflect and let's figure out what we need to do to make it right. So here's just some examples of what, if you don't know, if you've never seen a holodeck in Star Trek, this is what the room looks like with all the grid lines. Those grid lines are used for the for all the algorithms to lap in the scene, and then they put the scene, and this is what happens in the holodeck, and you interact with it just as if it was the real thing. You can see the Star Trek First Contact of the holodeck scene. I'm not going to really show the whole thing because it's not going to record very well, but
something inside in the nose.
So now they're in the holodeck. So that's an example of what it could be. Sorry. So if we use it and we apply the technology and allow it to help us teaching, we're going to have a lot less accidents in the 6 o'clock news. But we still need more future studies. We really need to see what simulation hours are really equivalent to and compared to the real world, if they were doing the real world hour theirs. So in the different areas, the different, chemistry, what do they need specifically for learning of the proper utilizing the tools? Biology, when they're using the different tools and graphing and putting them into, let's say, the oh my goodness, the really expensive, anyway, scope. I can see it in my head. Sorry, it's tired. But there are different things that we can think about that can calculate and figure out what rules and how much of it is applicable towards that 10,000 hour rule. If you don't believe that there's value for VR, AR, the simulation, that it's not going to be realistic enough, here's a guy climbing a tree using a VR. I personally do AR, but this is still VR. He's wearing the goggles, probably Oculus Rift, and he's going through. So he's practicing climbing. He fell. Now, he didn't hurt himself, but he fell in the real world. So it is very realistic. Here's another one. This is the roller coaster. So again, it's a roller coaster. He's standing there. He's not actually going through or doing anything. This doesn't take up a lot of room, not a lot of extra needed for this. So wrong, so funny, but so wrong. But that's just how realistic it is. I remember when the VR goggles first came out and we got those 3 or 4 years ago. and we put one on for my grandmother. My grandmother is one of those, oh, she's a hot pistol. But she did the roller coaster one. She was laughing and giggling, and it was fun. And then she wanted to do the haunted house one. And so she's in the middle of the living room Christmas haunted house. You know, she's looking around. Oh, crap! There's a clown! You know, and she's all this stuff and doing it. And we are all dying. I should have recorded it. I didn't. But even her, at the age of 82, was having a blast with it and doing different things with it. So I was like, oh my God, this is really, I'm on the right thing. So normally I like to talk to people. I like to talk back and forth. I like to bounce off ideas and go there. Obviously, it's kind of hard to do that using this format because it's a la carte, so to speak. You pick. But I would offer a chance for questions. If you have questions, if you just want to reach out and talk and brainstorm and get some ideas and things, please reach out. You have my contact information. It's right here. I have a website. I've had it for over 10 years. It's technologytoolshed.com. Goes to my WordPress, I believe, and also linked to it would be my Google account, the Google website that has everything on there. You can email me at any of my emails, and I'd be more than happy to answer any questions you have, to work with you, help you through different things. Maybe you decide, hey, I'm interested in this too, and I'm a PhD student or a master's student, and we can work together and write some different things about it. Now, for what you really care about, the game code. Dun, dun, dun. Game code. Game code time. Oh, okay, sorry, I'm weird. The game code for using simulation-based training to improve safety in the workforce in the classroom is 562917. I repeat, 562917. Well, thank you for attending this on-demand training. I hope you've learned something, and I hope to be hearing from you and we can share ideas, because that's how we learn. Have a wonderful and blessed day.